Hello everybody. Welcome back again to our series of tutorial in simulating microcontrollers in VS Code using Wokwi extension. So as I said, in this year we'll be using the extension one, not this web-based one. And yeah, there's no need for me to introduce myself. I'm Nicholas, and I'll be doing kind of get started or beginner level microcontroller simulation tutorials in VS Code using Wokwi. So today we'll deal with something called web server. So I'll try to divide it into only three big things, but or three big differences or three big parts. And in today's video, I'll only focus on one part, which is the asynchronous web server. Okay, the next one I'll just use the web server itself, and then the third one I'll use the WebSocket. Okay, so for today we'll be simulating one or unidirectional asynchronous web server with Wokwi. So the next video will be bi-directional, and after that I will start with the WebSocket, okay, where we'll be sending sensor data to the cloud, maybe using some other protocol like the MQTT or whatever protocol that we have. And I think WebSocket is much more better because it's secure and it's much more safe, faster also. So yeah, before I get into the topic, let me just show you. As I said, in 2025, we'll be doing most of our work using AI. Okay, we'll be using Copilot, GitHub ones, and here we have access to multimodal AI languages that we can use. So yeah, before I start with the course of today, I'll just give you an introduction of what we did in the last course. In our last class, we were just using this ESP32, and then here we got a display and three LED, two being just looping with blink, and this can be toggled using an interrupt push button. And the function was completely written by Copilot, and we use Claude AI as our base model to do this. So we did it together. It's very simple. I will just run it so that it becomes a refresher for us. So what we are doing here is to blink these two LEDs, and I think the first one is being blinked at 1 second, and the second one is being blinked at 250 milliseconds. I don't remember, but we can check here in the tasks. So the first LED, you can see here, it's being blinked at 500 milliseconds. This is LED number 2, I think. And this is for LED number 1, and you can see it's being blinked at 250 milliseconds. So this port take MS, just it's a delay function in FreeRTOS. RTOS stands for real-time operating system, which is used for embedded systems. And we are taking this 250, we divide by ms to convert it into millisecond. Okay, the same thing here. So these are for the two first LEDs, and the third LEDs was controlled using this ISR, which stands for interrupt routine service. So this ISR is being used to control the task of the LED. Okay, and what we do here is we just look at the edge. Okay, if someone or whatever the user press the push button, and we wait for it to go to the falling edge, and then we trigger the task by notifying this. So you can see this task is task number 1. So when the user press the push button, we notify this task that someone has pressed it, then we reverse the state of the LED. If it is off, we set it to on, and if it is on, we set it to off. So this was done last time. I will not waste too much time on it. As you can see here, so if I press this, you see it says on, and you see the state of the LED is also on. And if I press, it goes off, and you can see the state of the LED is off. So this was the beginner level or the entry level. So now today we'll be doing web server, as I said, and I'll start with a very basic one. Same thing, we have an interrupt or a push button which is connected to GPIO number 4, and we are using this GPIO as our ISR. Okay, our interrupt service routine will be looking up onto this LED, up to this GPIO. When this GPIO is high, we set this GPIO also high, which is GPIO number 5. And when this GPIO is low, we also set this GPIO low so that the LED turns off. Very simple. I'll first explain the whole thing. So here, also the very first thing that I'm also introducing to you is how files are organized in platform IO. So we get the vs.vs code where we have everything related to the extensions that we are using, and also some configuration about the compiler. And here the .py is everything related to our project, the libraries, the build files, and so on and so forth. They will be all here. So for example, here you see the build and you see the libraries that we have. So this build will have this name, this folder will be everything related to the development environment that we are using. Here we are using this board, the ESP32 DevKit V1, and that's why you see this name being like this as do it something. So this is the environment, okay? And this is the checksum of the project. But if you get into this, you will see, for example, everything like the partition table, the binary files, all of them, the firmware and the bootloader. So same thing in this one, we'll have everything related to our libraries that we are using. So let's say we have this library, we have this other library, we have this other library, and those libraries are here. Okay, they've just been called here, and these are the .py. Now in case that you don't want to have these libraries being used from the web, because these are libraries that are being stored on GitHub, and someone can get in and then modify it, and then your code will never work. So you better download it as a zip file and then put it into your library folder here. Okay, so here we'll put all of the library folder if we want to get rid of web syncing. And this include is where we put all of our header files. For example, you can see this is HTML file that we have here. So this is the page or the web page where we'll be pushing our information. Here is the header files of the main.cpp. So if you go to the source code folder here, main.cpp, the header file that we are including in here, you see here it said include main.h, is this header files here. So we can put all of the header files into our include folder. And finally, this folder we'll be using is the source code folder. Here's where we'll write most of our CPP files. Okay, so good. I hope first the file organization is good. Then I also took my time to write all of the comments here, so make things easier. And as I was saying, I'm using Copilot to make things easier for us. So in here we have two tasks. The first task is to control the LED, and the second task is to send the state of the LED to our web server, okay, which is a web page. I'll first start with this first task. This task is very simple. It doesn't have any setup function, so you can see there's nothing here in this area. It only has a loop function, a while loop that will be looping over and over. But how this while loops work, what it does, it checks the notification. If this notification is true, I would also tell you where this notification is coming from. And this macro or this function is a FreeRTOS syncing function. It's used to notify tasks. And when this notification is true, it performs this action. Okay, it reads the state of the LED, and then it writes it to the GPIO that we have set as the LED, and then it does it every 250 milliseconds. Very simple. Just read if this notification is true, then set the state of the LED by setting it to high or low, depending on what you've read from this. Very simple. Same thing here now. How this notification becomes true. For you to know how this notification becomes true, you have to get into where it's given. So this is give notification, and this is receive notification or take notification. So here's where we give the notification. But before we give them this notification, or what we are sending as notification here, depends on the state of our LED. So this is an ISR. So very simple. What it does is like, so go through the ISR that we will set, okay, this function, and go through, this is the bounce, okay, it's not the ISR. It's just when someone press the button, check the time that it presses minus the bouncing time that is set at 200 millisecond, the bounce delay. If that difference is bigger than this 200 millisecond, then you change the state of the LED. This is extremely important when you are dealing with push buttons, switches, and stuff that require user input, like pressing buttons. If it's not debounced, then it will just have some weird and weird behavior. So we add this for us to know if the person has pressed, because 200 milliseconds is really, really enough for us to say that it was pressed or it wasn't pressed. So if someone pressed, we start counting from the time that it touched up to 200 milliseconds. If the state doesn't change, then we say that it has been pressed. And when that is pressed, we write the state of our LED. If it was on, we set it off. If it is off, we set it on. And after doing that, we also restart the debouncing time. After resetting the debouncing time, we notified this task, okay, the LED task handler. So this task handler is null here, is defined here. And if you can check, this task handler is for this task, the LED control. Okay, if you also know to know where, you can just go to where the task is being defined. So you see here, create this task, and it's being controlled by this handler. We notify this handler that someone has pressed the button, and if this task has been notified, this notification is given here, and it has to be taken here. Okay, we take that notification, we check if it is true. If it is true, then we perform this action, which is to write the state of the LED to our GPIO. So very simple. This to this first task. Okay. Now the second task is we sending the state of our LED to the web server. Okay. If it is on, we send on, and if it is off, we send off. So in here, this is enable the corpse web browser. I'm not a front-end developer, but yeah, I think this stands for crossover operation, whatever. So it's for security level of the web server. So it just tells the server that whatever domains or whatever port or DNS comes, you can accept it. So it doesn't have anything, and it's really not that a very good approach, because it disabled all of the safety functions, most of the safety functions for the server. And this is only for the server. It doesn't have to do with our code. Okay, you can even remove it. It doesn't really matter. And then we have two routes here that are being set. The first routing is just, okay, routing just means giving away to something. So you are telling the server when the server is on, okay, since we're using this web request, we get the request to the using the HTTP GET, and then we need to send, okay, something, and this is what we have to send. How we are sending it, we are sending at 200 milliseconds. What we are sending this HTML file. So this index HTML is this in the here. Okay, I call it HTML dot. So if you click on this, it will get you to here, into this folder. So let me close it and get back here. So we are sending this where? We are sending it to an HTML template. So if you are also good in front end, so this HTML template has already been defined, and it's in the form of text. So we send this, whatever we've defined here, okay, our HTML file here, we are sending it to this HTML template. And then, sorry, we are here. And then we need a function to control or to handle, okay, how this sending process happen, because we are converting all this as a string and then send it to this template, and this function is in charge of that. Okay, so it checks into the template. Into the template that we have there, there's a spot or a place for on, and then a place for off, and that's what it returns. So this function's job is to handle the way we are sending our template to the HTTP protocol. So this is the first route. The second route that we're also doing is to send the state of our LED, if it is on or if it is off. So same thing. Okay, this is the send function in the request, and we are sending it every 200 milliseconds. Very simple. So in our processor, okay, this function, this second route will just update the position of this. If it is on, this will send on to there and it will become on. And if it is off, it will send off there, and then this section will also be set to off. Very simple. And after these two routes, we begin our server with server.begin, and then we print to the serial monitor that the server has started. And this while loop is just in there, be looping every 500 milliseconds. So every 500 milliseconds we'll be looping into our web server task. So simple. So these two tasks is what we only need. And then on this side we have the LED, which is being set as an output because it's directly connected to our ESP32 and set as an output. And then our push button is an input, okay, and it's also a pull-up input. It's important. It also helps us reduce some noises, even though we have the debounce function that is being defined. So we begin our serial monitor, and then we start our Wi-Fi. So we set the Wi-Fi as a stationary mode, and then we set the channel to 6. So just you can use channel 5, but channel 6 will just accelerate the Wi-Fi speed using Wokwi. And then after the credential, after beginning the Wi-Fi, then we need to pass the credential. So what is it? The SSID and the password of our Wi-Fi. So all of this also being defined in our main.h. So you see here, this is the SSID and this is the password, okay? And these are the GPL where I was saying, for example, LED pins and then push button pins, they are defined as GPL5 and GPL4. And if you want to also confirm that, you can just click on the diagram and you will see that the GPL is connected, the LED is connected to GPL number 5 and the push button is connected to GPL number 4. All right, so that was these two here. Okay, and these are the libraries that we are using. Okay, we need FreeRTOS for us to schedule taxes, and also we need it for tax management. Wi-Fi is needed because we need to connect to the Wi-Fi. The asynchronous TCP is used for us to communicate with the web server using this HTTP protocol, using the TCP as a transportation layer. And here we have the web server that's being used. Okay, this asynchronous web server that we're using for the ESP32, and this HTML.h is this file here, is our template, okay, that we have to send to the web, to the server. All right, now let's get back here. We were here. The credential has been passed. We print that the Wi-Fi is getting connected. If these two are correct, if the SSID and the password is okay, then it will get connected to it. And when it's get connected, okay, this is while it's connecting, it will be saying connecting. When it get connected, it will print that it's been connected, and it will say that it's been connected. It will also return the IP address of our Wi-Fi. And one important thing that we are doing here is also passing whatever value that we are getting from this port 80, because we initialize our server to port 80. Okay, we are passing it to another new host or local host that is called 8080 or port 8080. Okay, so we pass it to it and then we can display. And okay, last video I also show you how to create tasks and pin them to call. So this time we are not pinning it into any call, so we only have the task function. This is how you create a task function, the task name, the stack size, or the size of the memory that you want to use for that task, and this is this is the task priority and the task handler. So we are not passing any any core. We're not specifying which core, so it's up to the microcontroller to choose which core. And then this is our ISR, or the interrupt, or the routine. So we get the function, and then we set which type of interrupt that we want. Is it a falling or a rising one? And then we pass the GPIO on which we want to set the interrupt routine, or the ISR. Simple. So this one is not needed in the loop. We don't need that. So one other thing that you need to also do is to enable the Wi-Fi. Okay, the Wi-Fi configuration. We said that the Wi-Fi is enable. We are using Wi-Fi by setting this internet to true. These are not that much important. You can remove them because they are already defined into our main .h here. There are those two here for the credential, and also the channel. You can also remove it. It's not that much needed, but it's here. So, but what is really important is setting the internet to true, and then the port. As I said, we are forwarding the port. Okay, our target port is port 80. Okay, from 8080. So just as I said here, because I need to get a local host where I will display this information. All right, so this is 80. But most of the time, this port 8080 is most of the time occupied and being used by many people. You can use some other port like port 8180 or 8280 or whatever. Okay, so let's test it as we go. So it's already built. I will not have time to build for you guys. So this is the first exercise, or the first tutorial that we'll be doing. So this is just we sending one direction, or unidirectional, from our local to the web server. Okay, so as you can see, it runs and then it says it was connecting, then it says connected. After getting this info, and it says that it has opened a browser and you can navigate it using the IP address of the Wi-Fi. Another thing is it's also start an HTTP server, and it is at a local host which is 8080. So we can click on it and then it will open the local host. So you can see, very simple. We are only displaying the state of our LED status, okay? And this is our HTML template that was developed in here. Cool. So let's say, for example, I press on. You'll see that here it says the LED is on. The status changed here to on, okay? And that button changed. So let me bring this one down a little bit. So you can also see the LED is on here. If I press off, you can see it goes off. And when I press on, it says that it's on. When I press off, it says that it's off. Simple, right? So let's redo it again. So very simple. First thing is the HTML template that I've developed. So if you want to check how this HTML sheet looks like, you can just copy from where it's in. So this is okay. As I'm repeating, I'm not good at front end stuff, but anyway. So the HTML ends here. So let me copy it so that we can open it into a real-time web server. Okay. So I'll copy that and I'll create an HTML file. So I'll call it html.html. All right. So in here, I'll paste that. So you can see, okay, so this is the title of our web page. And then after that, we give this metadata. All of these are default stuff, okay? If you create an HTML file. So into the HTML, so we have the UI. We're using this font family, serial, UG, Arial, something, then the margin, the height, and all of that. So the body. So these are the CSS, okay, the CSS part, okay, of our HTML. So for example, how we want this one to be displayed, this title. So on the container side, so the container, I don't know if I have the page open or no, I don't have it. But anyway, let me open it so that you can see. You just right click and then open it with a live server. Okay, so oh shit, not that great. But yeah, anyway, so this ESP32 LED control is what is here, okay, the title, and how we want it to be. So this is the font and everything. Now, this container, for example, how we want this container to be, and all of that is being defined here, okay, on the container side. Now, the header, that header of ESP32, how we want to display. So all of these are the CSS part, okay, from here up to here. Okay, so these are kind of beautifying our website. And then after that, we have the JavaScript section, which will be this script. Okay, and it's a very simple script. It's just on and off. It gets the element by ID, which is the LED state, and if this state change, it also changes. It's just simple function to update the LED using JavaScript. So I will not waste too much time on this. We are not here for that, so let me delete it. All right, cool. So this is our HTML file, and as I was saying, let me start building it. And then in this main.h, there's almost nothing. We just have function prototype that have been here, or function declaration, the ISR function, the LED task, the web task, and the processing function. And this processing function is just for this HTML file. Okay, it's just for HTML file. It's to update on and off, okay, or write on and off on our website. And as you can see, it's being routed here, okay, and you can see this is the inside of that function. So it processes our template variable for the web page, and everything's at least defined here, and or let's say clarify. So let's build it. Okay, so our main CPP is being converted to object code, has been compiled by the compiler, and after that it will generate the linker file that will link all of these files into one ELF file, which will be our linker file, and it's called firmware.elf. And after linking all of this, then it will generate a firmware.binary, and we can flash our microcontroller using that binary file. Okay, and let's wait in a minute. That will be released in a moment. Ooh, computer's getting very slow. Okay, one moment. Okay, the binary file is here. Then for you to simulate, you can click on the diagram.json and then click on run. It will start running it for you. That is one option. The other option is click F1 and then start simulator. That will start. So click run and then it will start running. And the very first thing that will be done is first get into the core and then start the Wi-Fi. It was connected, and when it gets connected, it should return the local host. You can also use the IP address by just clicking on it, or you can use this local host address that has been added. And as you can see, a little bit beautiful, simple. So yeah, and by default our LED is off because this ISR hasn't yet been touched. So, but if I touch it, you can see it goes on. Say that LED is on, and also you can see here that it's also on. Isn't that good? Off, on, off, on. So guys, this is a very basic one just for unidirection, where we are sending information to our web server. Now let's get started with the other tutorial where we still have unidirectional, but at a little bit advanced level. All right, cool. Welcome back again, guys. And now we can stop this. We've noticed that this is working. And also you can see this because I added how to say that in English, a shortcut. Okay, you can also attach this push button to a shortcut, okay, as an attribute by using your keyboard. Let's say, for example, enter, or let's say you can choose whatever keyboard that you want. Instead of you clicking on it, you can attach it to a keyboard using a shortcut attribute. In French, we say raccourci, but sorry, guys. So yeah, good. We are good with this. Now, let's move on to a little bit better ones or advanced one that I've prepared. And yeah, just I did most of this for us to get time or to have much more time instead of me taking our time and then passing the prompt to the uh, Copilot. That would take time. I would just prepare all of them ahead of time and explain what the code is doing, and then we simulate it. So let's test this one, okay? F1 and then start simulator. So in here, we have a DHT22 that is connected to GPL number 5. We are reading the sensor value and then sending it to our LCD to display using I2C protocol, and at the same time sending this information to our web server. So cool. And this one I'm using the port 8280, so you can also use another port, okay? So I'm forwarding it using 8280. So it just means from 80 forward it to 80, from 82 forward it to 80, okay? Or from 8280 forward it to 80, because the server has been initialized at port 80. So cool. All right, so there's nothing that I can see here, so let me close this and then let me restart. Cool. So one thing that we can see that our thing hasn't yet started. Okay, let me do something like this so that we can have everything being displayed. My computer is a little bit slow, guys, but anyway, so you can see we have here the temperature, which is at 24.0 degree. We get here 24.0 degrees Celsius. We have the humidity and we have the heat index, and also we have the weather. Okay, if this temperature is in a certain range, we display a certain temperature status or weather status, sorry. So let me arrange this so that it can be seeable on all. Okay, one thing that I can do is to do this, but I don't like it that much, but let's do like this. Okay. So here we can change our temperature. Let's say, for example, we bring the temperature to 59.9. You can see it says 59.9, and here it said very hot conditions. So this is the weather status. And also it displays the NTC or the time, okay, that we have here directly from the ESP32 and synced also with our web server. Same thing, if I bring it down, let's say to minus 40 degree, it says that is very, very cold. Huh? But what the hell? Okay, yeah, minus 40 now, and get here minus 40. So it says freezing condition. Yeah, not even cold, but freezing condition. So let's say that I bring it to 3.6. That would be also kind of cold. So it said very cold weather. Awesome. So let's bring it to something like 16 degrees. So let's see what we get. See here, it says at 16.3 degree, that is a cold temperature, which is okay to me. 16 degrees, okay, it's okay for me. Let's say 26. At 26 degree, it says it's warm, so it's a warm temperature. So let's say we go below, so let's say like 22 degree. That would be pleasing weather. Okay, so let's say that we go above 30 degree by like 35 or 40 degree. That would be very, very hot condition. Let's go below like 30 something, 30 35, still very hot condition. So let's say 29 degree. At 29 degree, it says that it's a warm condition. So cool. Same thing. And you can see it's only temperature. When we change the temperature, the heat index will also change, because the heat index, it's a coefficient or a quotient between these two parameters, the temperature and then the humidity. So let's say, for example, I bring it to minus 11, you can see the heat index goes down. Same thing, let's say I bring it to a higher value, you can see also the heat index also change. What am I doing? It looks I'm displaying the heat index here, which is not correct. So holy cow. Oh yeah, no, I'm correct. So let's say, for example, I thought the temperature was equal to the heat index, which is not true. So let's say you change the heat index, so let's say higher. Also, this heat index is also changed. So this is the humidity value, okay? The humidity value right now is 72%, and the heat index also goes up. Okay, so if I bring it down, the heat index also go down as the humidity goes down. So now let's see how this is being done, okay, on the code side. Very simple. Let me stop this. So same thing, we have our main.h where we define the GPIOs or the hardware connection. So here we get our DHT that is connected to GPIO number 5, and then we get an LCD that is connected to 21 and 22 on its SDA and on its SCL, the serial data and the serial clock. Here we define the address of our I2C communication, and we define the stack size of the task that we are being used, okay? And then we define also the updating interval of our web server to 1 second. And as external class, which is the asynchronous web server, we create an event and we declare some new functions, or we initialize some new functions that will be used into our main.cpp. One is the Wi-Fi task, one is the server task, and one is the sensor task. And this is just a function that will be called into our Wi-Fi task or our server task to pass our HTML template to our server. So then let's go to our web.h. So this is what we can see here. And for you also to visualize what you have, you can come up to this end of the HTML, copy it, and then paste it into an HTML file so that you can visualize it. Make sure that it's okay. So I'll call it, let's say, template, okay, .html, sorry, since it's an HTML file. So I'll paste this one in here. Then let's just open it with our live web server. So let me close this. So if the live web server, it says that it started at port 550, and it should automatically launch it here. So this is how our web server, this HTML file, this is how it looks like. It has a JavaScript that will pass, okay, most of our values using get element by ID to pass, okay, the values of these 3 parameters. Also, this 4th one, which will be the weather condition, and the time is directly synced with our time from the computer. So today is Sunday, March 16th, 2025, and right now it is 11 at my place, 37. So this is how you can first see how your web server or your HTML file will look like. If you're convinced with this, you can make this one as a constant, okay, which will be a string, okay, as just one parameter of our code. Okay, so let me close this and also delete this file which is not needed. Now, if we get in here, you can see that we convert all of this web page into one thing that we are calling here as HTML template. Now we need a function to get this variable into the route of our server. So that is where I don't need this, and bring this on high. This is where we'll get this get HTML file. So this route, it just requests and then it sends our HTML page to this HTML template every 200 milliseconds. And if you click on this function, you can see that the function is just here and it's not doing anything. It's just taking this HTML template, okay, returning it. And the HTML template is this, just that, nothing more. So this function get HTML just return our template, and when it returns, we pass it to our server, okay, when the server is on. And then we have an event, and this event will just go through our variables and then update them based on their last ID. And we have this task handler. But as I said, I'll first get back here so that we can go through each function. So this Wi-Fi task, I've already just explained this get HTML. It just return this web page that we have here. And this web page is just 3 things: an HTML file, a CSS file, and then a JavaScript file here. Okay, this is a JavaScript file. And this will display the time and also display the values of our temperature, humidity, and heat index. So this Java script function is to do that. And this HTML, this CSS part, which starts from this div and then ends over there, is just for to beautify our website. And then the HTML function, the HTML part is just this little part where we get the header file displays and the temperature names and the value, the temperature names and the humidity name and the heat index name. And then the style here, which is our CSS function, is end here and then start there and then end here. So all of this is just to beautify. If you remove this from here up to here, the website will look very, very ugly. Okay, good. So that was the very first one, which is this get HTML. Now let's go with the Wi-Fi task. The Wi-Fi task is very simple. It's just to initialize the Wi-Fi using the SSID, the Wi-Fi channel, and the password. So let's get into that. So I'll click on it and then it will bring us into our Wi-Fi. So as I was saying, it will first begin our Wi-Fi, passing the SSID and then the password, and then it will wait if it gets connected. When it gets connected, it will say it's connected by printing this serial and also our local host, so that we can just click on it and then open our web server or our web page. And then finally, it also print the local IP. And when that is done, since all of these tasks are synced, it also has to notify, okay, the other event that yeah, this is okay, by giving this notification. Given to whom? Given to the server task handler, okay, which is the server task here. So when the Wi-Fi is okay, this will start. If this doesn't give that notification, this will not start. So this is how FreeRTOS works, because we want to sync all of the tasks, okay? So when our Wi-Fi is okay, it will notify the second task, which is our server task, that I'm good, then you can start. Now, if the Wi-Fi task is okay, it gives this notification, and this notification has to be taken here, okay, by our server task, because this server task handler, which is here, is being used by the server task here in the task creation. Can you see here the task handler? Now, since the notification has been given by our Wi-Fi task and it's been received, and when it's received, it has to be true. Just when it's true, it means that this task has been performed properly. When it's received with the delay, okay, this is just the delay that is being defined, and also is defined, okay. You can check in our global variable in main.h. Now, if this task is okay, the notification has been received saying that we are good, it has to start this route. It first create the first route, which is our HTTP get route, by sending this request. And this request will be sending every 200 milliseconds using this test template, which is from our get HTML function. And this get HTML function is this function here. It's a string. It just converts all of our web page into a string that can be displayed to our website. We good up to here. Now we create an event. This event, on connect event, it check our last ID using this last ID to print if the client, someone has been connected or not, and then return that to the client using also the server handler. And then we begin our server. This is not that much important for us, and it just tells us if we have a client that's been connected and get the last update of that, and then print someone is getting connected or someone has getting connected, or someone has request this, okay, this web page from the server. And then we start our server with the server begin function, and in the while loop we just be here turning every second. So this task is also very, very simple. It doesn't even need to be a task. You just have to route this, and then Also, you could have just started, if you know that your Wi-Fi is stable, you don't need to notify another task that the Wi-Fi has been connected. It can start. And finally, our last task, which is much more important, is our sensor task. So this is a very long task, as you can see. What it does, it first call this LED function to init, and this LED function, LCD function, what it does, it clear our screen and then print the temperature and then print the humidity and finally print the heat index or HI. So I will not explain how LCD works. So clear just means clear the whole screen. Set the cursor to 00 means go to column row 0 and then column 0 and then write this string there, temperature, and then set the cursor to another row, so the cursor to another row. So now let's get back here. In here, when we call this function, then we create 3 strings to hold the place of our old values. So we have temperature old, we have humidity old, and then we have heat index old. So these are the previous values that we need to store. After storing them, then we create 2 variables, which are temperature and humidity. Now, this is where everything gets done, okay, in the while loop or in the for loop. It's just a loop that will be done every uh, time that this update interval is passed. So I think it's 200. Yeah, 1 second. So it's 1 second we'll be reading the temperature. We update the temperature every second. So let me get back and explain this for loop. So we start with an if condition. We will read the temperature and then humidity, these 2 values. We check if they are numbers. Okay, if they are not numbers, okay, if they are not numbers, we directly get into the else function, which is not here. Okay, we just say that it's not a value, or DHT initialization error if they are not numbers. But if they are numbers, okay, if these 2 are numbers, then we get into this function. So we compute the heat index. If this temperature and humidity are numbers, we are able to compute the heat index. After computing them, then we set these values as new temperature and new humidity and new heat index that we need to display them onto our website. Okay, but let's not go onto the display now. Then we also get into functions that we need for us to initialize this, because if we don't do that, our initialize or init LCD label will be just running all the time that we get new value. Okay, but what we need to know is the new value that we've gotten, is it different from our old value, the previous value of temperature that we had, and the new value of the temperature we have? If they are the same, we don't need to update this function. Then we will not call anything here, we'll just jump here. But if they are different, so that means something has happened. The temperature has changed. If the temperature has changed, then we need to update that unique value on our LCD on the display side. Same thing for humidity and same thing for temperature. So let me just run it so that I can show you what I'm talking about. So here we have temperature that will be displayed, humidity, and then heat index. What we want to do is not just every, because this task is called every second. So if every second we have to refresh the screen, then this LCD, the core, can get tired. So what we are planning to do here is we will only update the part that get changed. Okay, so if I do this, the temperature, so it's only the temperature side that get updated, and since the HI or the heat index also get updated, so both get updated. Although this task is run every second, so we only update when we get a change. So that is what we are doing here. So if our new temperature value is different from our old temperature value that has been already stored, then we refresh our LCD. If not, that is not the case, we just keep our LCD the way it is. As you can see here, nothing is getting changed intact. Nothing is getting changed until there's a change, until the temperature value or the humidity value varies. So let's open our web server. And so I'll try to see if I can put both of them on the same. Okay, and then this here. Oh no, this is not what I want. I want, okay, let me do this and then do this. Let me refresh this. I don't know. Okay, and I was on this one. Cool. So this is what I want to display. So same thing as I was saying, we don't refresh our LED, our LCD, unless the value of the temperature get changed. So for example, if the humidity changed, we'll update the humidity value. And since when the humidity change, the also heat index also varies, we also update both of them. Okay, awesome. So I think this is simple and useful. So it's a DHT sensor that we are using and then sending the same value exactly to our web server, and then we update our web server based on the weather condition also. So I think that is it. Very, very, very simple. We only have mainly one task, which is the sensor task, because all of the other tasks can be just as function, unique function, and can be called outside. And yeah, I also here, yeah, these are the three tasks that has been defined here. So the function of the task, the name of the task, the stack size, and the task handler, and the priority level of each task. And we start the wire, which is the underlying function of I2C, by passing the serial data and the serial clock. And you can also pass the address, but you have to pass the address to um, the LCD. Okay, so this is the address, and these are the pins where the LCD is connected. So guys, I hope this was useful, and we will move on now to the other section, okay, of our work, which is sending information from the web server back to our hardware. So this is the hardware that we have, and we are sending this information from the hardware to the web server. Let's say, for example, if I do this, I read this sensor value, display it here, and then send it to our web server. Now, what if we want from the web server, we perform an action here and that gets sent to our hardware, okay? So let's do that. But both of them are called unidirectional because we are only sending in one direction, okay? Or we send from this to here, which is also one direction. And the third part or third tutorial will be how to do multi or bidirectional communication between our hardware and our web server. So I hope I'm good, and we can continue with that in our next section or our next video. So I would like to make this one a little bit shorter, and I will stop from here. Thanks guys for watching, and see you in our next tutorial where we will do server to hardware.